A block of mass m1 on a horizontal table is connected to a hanging block of mass m2 by a string that passes over a pulley as shown below. The acceleration of the blocks is 0.6 g. Assume that friction and mass of the string are negligible. The tension T in the string is. This is something that we are going to solve in this episode of Physics is Easy with Mr. Jesse. In dealing with problems related to a system of masses, it is always important to look at each mass individually, so we would analyze the forces that are acting on each object separately. So say for example, let's look at M1. Now M1, it's on the table, so M1 will always have the force of gravity acting on it, and I'm going to call that W1, or weight of mass 1. And since it is on the table is also going to exert a force on M1 which opposes the force of gravity, and that's going to be upward, and we call that the normal force. Now since M1 is not moving in the vertical axis, therefore we could say that the normal force is just equal to the weight of mass 1. But there is another force that is acting on mass 1 which causes this acceleration, and that is actually the tension. So when something is connected to a string, wire, or cable, there will always be tension acting on that particular object. Now this tension right here is the reason why the object is going to accelerate to the right. Okay, obviously in this particular scenario, you could never expect M1 to go to the left, because if M1 goes to the left, then therefore M2 goes upward, and it just doesn't happen. Alright, so it would violate the laws of nature. Okay, so if we're going to use Newton's second law of motion, so that's going to be F net is equal to ma. We're looking at M1 right now. So the forces, or the force that is acting on M1 that would cause M1 to move or accelerate, would only be tension, because again, normal force and weight cancels out. So that's tension is equal to the mass of object 1 multiplied by the acceleration. It is also very essential for us to determine the direction of this acceleration. So since the acceleration is directed to the right, we call it positive, or we consider that positive. But if it's directed to the left, then the acceleration here should be negative. So that is our M1. And rather, the forces that are acting on M1. And we are going to substitute acceleration with 0.6 g, so that we are going to have T is equal to M1 multiplied by 0.6 g. Now g right here is the magnitude of the acceleration due to gravity. It's not grams, it's the magnitude of the acceleration due to gravity, which is 9.8. Okay, so now let's look at mass 2. For mass 2, the forces that are acting on it would just be the weight of mass 2. So that's, I'll call that W2. And we also have tension. Since mass 2 is connected to a string, there will be tension acting on it. Now, we cannot say that tension is equal to the weight of the object, because as a matter of fact, or weight of M2, because as a matter of fact, M2 is going to accelerate downward. Alright, it is going to accelerate downward. So if there's acceleration, therefore the tension here and the weight here will not cancel out. Also, you have to remember that if we have masses connected by a single string, the tension on one mass should be equal to the tension on the other mass. So therefore, we are not going to call it T2, but just tension, because again, the tension in mass 1 is just equal to the tension in mass 2. So applying Newton's second law of motion, that's for mass 2, that's going to be F net. That's going to be F net is equal to m times a, and we have the forces acting on mass 2. We have tension going up minus the weight of m2, so that's negative because it's going down, multiplied by mass of m2 multiplied by the acceleration, but this time since the acceleration is going down, so we consider this to be negative. If the acceleration, or if the object was going upward, then we will have the acceleration to be positive. Let's expand this. We are gonna have tension is minus the weight of, or W2 is just equal to the mass of object 2 or m2 multiplied by the magnitude of the acceleration due to gravity, and that is equal to m2. And we are now going to substitute a here with this value 0.6 g, so I'm going to write negative 0.6 g. Let me just make this clear. This right here is m2, so that's m2. Alright, so if we are going to look at the choices, B is actually the answer here. So we would try to express tension, which is being asked in the problem, in terms of M2 and G. Alright, so simply we could just transpose, we could just look at the second equation, and by transposing this term to the other side of the equation, then we are going to have tension is equal to m2 times negative 0.6 g plus m2 g. So again, I am just transposing this to the other side of the equation. That's why from negative it will become positive right here. Alright, rewriting this, I'm gonna have negative m 0.6 m2g plus m2g would just be equal to the tension, and that is going to be equal to 0.4 m2g, which is the answer to this particular problem. And that concludes this tutorial. Once again, always remember, physics is easy with Mr. Jesse.